In this AstroPictionary Math problem, we want to calculate the fraction of hydrogen mass used in nuclear fusion energy reaction. Let's take a look at the pp fusion chain, which occurs inside the core of the Sun. We have 4 protons, or 4 hydrogen atoms. A hydrogen atom generally has a proton in it with an electron orbiting it, but the electron's mass is so much less massive compared to the proton that we basically ignore the electron's mass. So we have 4 protons that will fuse together to ultimately generate 1 helium nucleus. Now, in the process of generating this helium nucleus, there is a mass difference. If you add up the mass of the 4 protons and you take a look at the mass of the helium-4 atom, you'll see that they're not the same. The helium-4 atom has a less mass than 4 protons. The 4 protons, if you multiply them all out, 4 times the mass of a proton, you get a value, and that value is higher than that of the helium-4 mass. And therefore, you have a mass difference of which is 4.59 times 10 to the minus 29th kilograms. And if you want to see this worked out, see this video I created at https://youtube.be/HOO, Now I give you some constants and the equation E equals mc squared from Einstein's famous formula. However, we're not going to need it in this particular problem. Our goal is to find the percentage of 4 hydrogen mass that is used for conversion into nuclear fusion energy by generation of 1 helium-4 nucleus. Now we know that if we take 4 hydrogen atoms and we multiply that by 4 by the mass of the proton, we're going to get this total mass. We want to know, of this total mass, how much of it is being used for fusion energy. Well, the mass difference that is going to be used or mostly used for fusion energy, after all, we have mass being carried away by some neutrinos, but that is small. So we'll assume all of this mass is being used in nuclear fusion energy. So we're going to write this value down. This is the amount that's available. That's the mass difference, 4.59 times 10 to the minus 29th kilograms. That's the amount of excess mass that's available for fusion energy, of which most of it will be used. And this is the amount of mass we started with. Let's divide out like units. Kilogram deletes with kilogram, and we're left with a fraction, which is unitless. Now we just need to calculate it out. 4.59 times e to the minus 29th, 4.59 e minus 29. We want to divide that by 6.6904, 6.6904 e minus 27. Let's check. That's 10 to the minus 27th. So we hit equals, and we have a value of 0.00686, 2 zeros. 0.00686. That's the fraction. Now we want to find out the percent. Well, the percent is just the fraction times 100. So you take 0.00686 and multiply that by 100. Well, we can just eliminate 2 of the zeros and we'll end up with 0.686. If you want to check it, you go back to your calculator and say multiply by 100, and you get 0.686. So our percentage is 0.686. So what this means is for every proton that we start with, of the mass of the proton, only 0.686% will be used in nuclear fusion energy. So if you have 4 protons, and that mass is going to be 6.6904 times 10 to the minus 27th, only 0.686% of it will be used in nuclear fusion energy.